Hello, Piotr. Thank you very much for accepting to create this video in the series of videos for our cost action. You are one of the very active persons in the network, and let's produce something that will help the others, members of the network or other stakeholders, understand what is all about. So before giving you the floor, I would start with the first question. So what was the aim of the project that you have proposed?
Okay, thank you, Vasile, for inviting me. It's a great pleasure always to meet you. So basically, the aim of the project was maybe I'll start with the title. So the title was exploring research visibility of the finite cost action members, a bibliometric analysis of topics. So as all of us know, exploration and kind of quantification of scientific output is very important in every scientific area because it helps to understand what we do. And our action is quite large. We have more than 200 researchers from 48 countries, which do a lot of research in different areas, different topics. Right? We have 3 working groups which focus on various aspects of applications of AI in finance. And what is more, we promised several deliverables, among which there are also reports and discussion papers. So we wanted to measure the result and the content of the papers or articles which were published by our action participants so far to understand if they fit more or less to those deliverables. We specifically focused on the deliverables which are still in progress, right? Which we may still give some hints about or some help to our participants of how to proceed. So basically, that would enable us to identify already published papers, which can serve as a basis or maybe a supplement to those deliverables which are still to be done. Right. So what's more, the last deliverable of our action, which is promised by us, is an edited volume, a large book of which would contain scientific achievements of our action. So we think, because we did it in cooperation with several people. Let me also mention that I did it with my PhD student Maciej Świtała, but also Professor Wolfgang Herdle was involved, Koruta, Mare, Daniel, Trajan Pele, Raul Bach, Jörg Osterrieder, Ala Petukina, and Daniele Marecina. All of us worked on that. And we think that this kind of comprehensive analysis of scientific output of the action may give interesting insights for those deliverables and also for this final outcome, which we promised to prepare.
Thank you, Piotr, for this clear description. And obviously, it's an important added value, and it's going to give a very good understanding to everybody reading about trying to understand this action, what was done, who, what are the correlations, collaborations, and so on. And in terms of the framework of the analysis that you've used, can you share some details?
Yes, so as I already mentioned, we focused on the papers among deliverables which are still in progress, so which are promised to be delivered in month 48 of the action. It includes 3 deliverables. Let me mention them because it's important. So deliverable 10, which is a position paper and roadmap on mitigating risk connected with the increased use of digital assets. Deliverable 11, which is methodological discussion paper on the design of stress tests for the evaluation of AI and ML models under shifting financial conditions to improve the robustness of models. And also deliverable 12, which is a methodological discussion paper on AI models to generate failed trials of investment product producers and on quantitative strategies with the usage of the promising field of network data analysis. So it's a very complex set of areas which we need to cover and to solve the puzzle, to check how well our current or research up to date fits to those deliverables, we analyzed all publications of the participants of the cost action as of the end of March 2023. We scrapped those publications from Google Scholar. And basically, as our action focuses on financial applications of AI, risks related to digital assets and so forth, we limited because our participants are also active. They published a lot of papers. We have professors who work for many years. So we limited the sample to the papers which were published after, not earlier than in 2010, because we assume that 2009 is the birth of, let's say, Bitcoin. So that's the beginning of, in fact, the evolution of digital assets. So we didn't look on the papers which were published before 2010. Then among the papers which we scrapped from Google Scholar, there were also, Google Scholar includes many different types of inputs. I checked my own profile, and I saw that there are, for example, handouts for students, some strange inputs which are not of our interest. So we excluded the papers which do not have any journal title, right? So only the articles which were either published in recognized journals. The journal title in Google Scholar also includes the phrases like working paper or proceedings, which means that this could be some papers which are not yet published, but are, I would say, also not didactic elements, right? So we performed the analysis on two different, let's say, types of text data. So we analyzed the titles of the papers and the abstracts separately, so descriptions of the papers. So we had about 8,000 of unique records, which represented scientific publications which have not empty title, and also about 5.5 thousand of papers which have non-empty abstract, which was quite a large sample. And as we focus on three phrases, then we focused on three phrases which were included in those deliverables, which I mentioned before. So we checked if those papers relate somehow to one of the phrases. One was risk of using digital assets. The second was stress test for AI evaluation. And the third one was financial failed trials. So what we did, we clustered all the published papers into homogeneous topics. We tried to group them in clusters of similar ideas behind. Then for each of the clusters, we identified keywords and then checked how well the keywords for those topics correlate or relate to the phrases from our deliverables. We wanted to identify which clusters, which topics from the papers which we already published might fit well to the deliverables which we have still to prepare and finalize.
Thank you for all these details, Piotr. One simple question. So it seems like you've approached the problem with a very complex methodological view. And is this methodology that you've designed, you've seen it in other reports for other cost actions, or is your innovation, like the group's innovation for this approach?
No, this is the methodology which is, we use the state-of-the-art methodology from the natural language processing tools, right? In particular, topic modeling. So shall I explain the details about this? Yes, basically, topic modeling is unsupervised machine learning tool which identifies clusters or groups of similar words within the body of a text, right? So it tries to use semantic structures in text to understand unstructured data without predefined tags. So we try to group together text corpuses based on, let's say, patterns which the method identifies there. So based on word frequency, the order of words, the distance, and meaning, right? There are methods to identify if words are similar or not. And then topic modeling puts together the identified items into relevant categories without the predefined training. So we do not assume the number of topics in advance. We don't assume what they include. We just let the data speak, right? That's why it's unsupervised learning. So of course, there are many different types of topic modeling, and we used, as I mentioned, state-of-the-art method, which is called BERT topic algorithm. So it's based on transformer neural networks, which are a hot topic right now, because you may have heard about ChatGPT, which is another like GPT comes from generative pre-trained transformer, right? So BERT is also the abbreviation from bidirectional encoder representations from transformers, and these are methods which represent text as vectors, as numbers, so that computers understand them, right? So they represent each word as a series of numbers, which to some extent summarize the context in which those words were used in the sample on which the model was trained. So if the two words are similar, they will have a similar, it's called embedding representation, right? So we try to make this together. So BERT topic algorithm, which we used, is a variant of the BERT method, and it involves subsequent steps. So first, we represent text as vectors. This is called text embeddings, it might be high dimensional, because every word might be represented by let's say up to 1,000 of numbers, depending on the context, how much training data also we have. So then we need to reduce the dimensionality of this data to perform efficient computation, and based on the similarity of words, we try to find clusters of documents, group them into topics, and then once we have the topics, we make the analysis, let's say, to identify the keywords of each of the topic, right? So we check which words contribute the most to the particular topic, which words appear most often, or identify the topic, distinguishing it from the other topics. So basically, once we have a topic and keywords, we can check how those keywords are similar to another phrase which we want to compare it with, right? So here, of course, the I would say mostly used metric, which is applied to text data, is so-called cosine similarity, which is like, let's say, correlation. It takes values between -1 and 1. The higher the value is, the more similar the texts are, right? So we used cosine similarity to identify the correlation of topics which we obtained with the phrases which we looked for in those topics, right? So we try to find most similar topics to those deliverables which we need to deliver.
It seems you've mentioned the deliverables of your project and of the cost actions again. So they feed into the deliverables of the action in general. In terms of research outcomes of your project, what would be something that you think necessary to mention?
Okay, so as I said, we performed the analysis separately for the titles and also for the abstracts of the articles. And based on the titles, we identified about 340 different topics. And more than 2,000 of articles which we had in our data were not classified to any of the topics, because BERT topic assigns probability with which a particular article or text belongs to a particular cluster. So there might be texts or articles in our case which are in the middle. It's somewhere in between. So they are not classified to any of the topics with high probability, right? So that's why some of them are basically somewhere in between. In case of article descriptions or abstracts, we identified about 220 topics, so a bit less, and less articles were not classified. So longer texts allow to classify those texts better, right? So with higher probability. And as I said, we looked for three phrases in the text. The first phrase which we looked for was risk of using digital assets. And among those 200 or 300 topics, we found some topics which were very similar, related to risk of accessing bank and models used to identify this risk, network risk and uncertainty, systemic risk, cyber risk. So I would say that in case of this first deliverable, which we still have to prepare, the research of our action participants is already well established. So we have a lot of papers, a lot of subtopics which fit well, which somehow might be used to prepare the deliverable summarizing risk of using digital assets. The second phrase, which we analyzed, was stress test for artificial intelligence evaluation. And there was one of the topics which perfectly fitted to the first part of this phrase. So stress tests, right? Stress tests were done by many of our action participants in many papers. There appear keywords like stress testing portfolio, model stress testing, risk to the banking sector. So stress testing is well understood, and we clearly have it. There were two other topics which also dealt with similar research. However, in neither of the topics which we identified, there were keywords which related to the second part of this phrase. So AI evaluation, right? So using stress tests to evaluate AI applications, which might suggest that there is still a gap in research of our action participants. So we don't have research which is already published, or at least prepared as a working paper, which might cover the use of stress tests for AI evaluation. So I think it requires further investigation. We need to check, particular articles that belong to the topics that we identified, but still looks like there is a gap. And the last phrase which we checked for was finance phase trials, and here only based on the abstracts, so the longer texts, we identified one topic which has the keywords that relate to failed trials, and those keywords were like defaulted loans, unsuccessful innovations. So they do not really, in fact, fit again to the idea behind this deliverable, because let me remind you, the full title of the promised deliverable is Methodological Discussion Papers on AI Models to Generate Failed Trials of Investment Product Producers and on Quantitative Strategies with the Usage of Promising Field of Network Data Analysis. So we thought that the phrase that we used, finance failed trials, could be too simplistic representation of this long title. And that's why we also applied the analysis to the extended version of this phrase, that was AI models to generate failed trials on investment producers. However, although we obtained some topics which better fitted to the idea behind this 12th deliverable than with this short phrase, still the similarity of those topics to the phrase was relatively low. So in the end, we concluded that in this case, again, we might have an important gap in the action participants' research, because there are no research so far. There's no research so far which can fill the requirements for this deliverable, which we have, right? So it also shows that the topic modeling requires clear and informative phrases. So short phrases might be too simplistic representations of some ideas which we want to check. So we need to really provide informative phrases to get meaningful results.
And in terms of, because you've mentioned these gaps, in terms of future plans, where's the group planning to go, or at least you, what do you have in mind?
Yeah, of course, this is the work which can be always extended, right? So we have a paper which is published on SSRN so far, which can be accessed, by anyone, and we believe that this offers some kind of interesting overview of what we did, but still there are things which we need to do. So basically, as I mentioned, we plan to identify particular articles which best represent each of the topics and which might be related to those action deliverables which we need to prepare. What we also want to do, we want to perform some network analysis in division into topics. So we want to identify if there are groups of researchers in our action that cooperate doing research on specific topics or ideas. So if we can not only divide our research into topics, but also the subgroups, right? So this may show who may work on which topic, but also whose research is most useful, right? So far to provide best input for the deliverables. Of course, we want to present the results of this research on one of the action meetings. We want to prepare the Quantlet with the codes. But generally, we need to dig more into particular articles which might be useful and show also potential topics which are not covered yet, in which our action participants may cooperate and find partners for joint research and research projects.
Thank you very much, Piotr, for all these details, and I'm sure that everybody waits to see the presentation in the next meeting, but also when deliverables will be available for the larger public. Probably they will be very interesting. And one of the objectives of us recording this is that whoever finds the topic interesting may reach out and get in connection with you. So thank you again for accepting.
Thank you very much.